In this video, we will look at an example exam question for specification point 1.4. Let's start by reading the question. A student investigates the motion of a toy car as it moves freely down a slope. The student wants to find the link between the starting height of the car and the speed of the car at the bottom of the slope. Part A. State the independent variable in this investigation. The independent variable is the variable that you change during the investigation. The student wants to find the link between height and the speed at the bottom of the slope. So, they must be changing the height, and therefore this must be the independent variable. Part 2. Suggest a link between the starting height of the car and its speed at the bottom of the slope. Well, if the car is higher, it will have more gravitational potential energy, which will then be converted to kinetic energy as it moves down the slope. If it started with more GPE, it will have more kinetic energy at the bottom of the slope and therefore a greater speed. So the link is that the higher the starting point of the car, the higher the speed at the bottom. Make sure you state this explicitly rather than just saying something like it increases. Part B. Describe how the student should measure the starting height of the car. Looking carefully at this, we'll see it's a 2-mark question, so you need to say something more than just with a ruler. So it's good to try and visualize how you would actually make this measurement. If you are changing the height and want to measure it consistently, you will have to make each measurement from the same point. So our answer can be with a ruler to get 1 mark, and always from the same position to get the 2nd mark. Part C. The student describes how she will find the speed of the car at the bottom of the slope. I will start the timer when the car begins to move. I will stop the timer when the car reaches the bottom. I will find the speed at the bottom by dividing the distance moved by the time taken. The question says, explain why the student will not be able to calculate the correct speed using this method. Well, at first glance, her method seems okay. But the question asks for reasons that it's not okay. So let's reread the question to make sure we haven't missed anything. The question says, the student describes how she will find the speed of the car at the bottom of the slope. On second reading, we can see the student wants to find the speed only at the bottom of the slope. Her method applies to the whole slope, as she starts the timer from when the car sets off at the top of the slope. So, in fact, her method would find the average speed of the car, not the speed at the bottom of the slope. And so her calculation must be incorrect. So our answer will be, the student's method calculates an average speed across the whole slope. The speed at the bottom will be greater than this, and so her calculation, and therefore her method, will be incorrect. Next question. Describe how the student should take the measurements needed to find the speed of the car at the bottom of the slope. You should name any additional equipment needed. So here we can use the ticker tape method that we discussed in the previous video. We will not waste time and space detailing the setup, as the question is more concerned with the measurements. So, 1. Attach the ticker tape to the trolley and feed it through the ticker tape machine. 2. Use dots at the end of the tape, as this corresponds to the journey at the bottom of the slope. Measure the distance between 2 dots, convert it to meters, and divide this by 0.2 seconds to find the speed. Okay, next question. The student repeats the experiment using the same equipment and the same starting height, she finds out that the time taken for the car to move down the slope is not exactly the same for each experiment. Suggest 3 reasons why the student gets different results when she repeats the experiment. Time for a bit of common sense here. We need to think about the reasons the time could vary. 1. The student's reaction time could vary. 2. The car might not always be travelling in a straight line. 3. She may have misread the time. 4. There may be a draft or a wind changing the amount of air resistance. 5. The measurement of the height might actually be inaccurate. When there are lots of options like this, it is best to pick those which have the most impact or is the most likely to have occurred. So let's go for changes in human reaction time, 2. The car not travelling in a straight line, and 3. The measurement of the height might be inaccurate. That's the end of this video. Move on to the next video to learn about the relationship between acceleration, velocity and time.